Hello everyone, Peter here, Piotr Fissner, guys. So let's look at this beautiful, how you like it, I don't know. That's LG. So LG means a better quality check, and should be better quality that doesn't come with Vestel power supply, so that shouldn't be a problem. Now this has completely no power, it's dead. So I want to show you. Dusty, call it dusties. Yes, it's really dusty and nasty. So I'll take it out. There's just a few screws, so I won't be wasting your time. I'll be back in a jiffy, and we will see what we can find over there. There is no even LED at the front, you know, completely dead. I've checked, $40.99 plus $4.50 shipping on eBay, pounds. So that's over 50 quid for the power supply, which is, you know, which is worth checking in that case. Yes, let's see what's wrong. If we've got not even standby power, we should be able quite quickly to diagnose what's wrong. Yes, but first tidying up and using my resistor, which is 5 watts 100 ohms, to short capacitors to not get electrocuted, because I don't want to do it. And I'm not using screwdriver because it's popping out noisily, plus it's damaging capacitors when you're doing so don't do it. Order 5 watts 100 ohms resistor and discharge this way capacitors if you know what you're doing, and if you won't get, you know, killed, because that's the way to do, like pros, do it like a pros. Okay guys, so be right back. Okay guys, so the first thing what we've got is, we know, because I've connected to the mains, and I know there's completely no power. So that's mean power is coming through this connector, and it has a fuse, yes, which is here. So the first thing which we should check is this fuse. Is it only a fuse or maybe something else? Yes, then we can follow the diagram. That's a hot side. Okay, here it's drawn even how the hot side goes, and then this part is a cold side. That's mean here you can touch and it shouldn't kill you. Yes, pretty much. Not everywhere. Here I'm not sure exactly how much is amperes going, but it's LED, so it shouldn't. Just in case, you know, don't touch anything by hand. So what it is, before me checking even the fuse, I want to check this capacitor. That's 100 microfarads for 50 volts. I want to check on the 2000. That's not too much. Let's make it 200 microfarads. I want to just check it just for myself. I know it's in the circuit. I shouldn't do it in the circuit, but I want to check. Oh, actually that's about 100 microfarads. 90, about 94, which is okay. I just wanted, you know, because that's the main capacitor. Yes, I wanted to check it. If that would be about 90 or less, then I would be worried, and I would recommend even to change it, even though you know, it's still okay. Yes, because I don't want to open this TV if I really don't have to. So yes, so the first thing is the diode mode here. Yes, diode mode. Let's switch it on and let's check if the fuse is okay. Oh, fuse is dead. Okay, so now we know what can be the cause of this. Yes, it's one, it doesn't beep. So if we've got a fuse faulty, guess what? Of course we can have a problem. I'll get soldering iron. Oh guys, you flied away. Okay, I'll put you aside, it will be more convenient for me. what I want to say is I won't do it the proper way. I will do it only for a testing purpose. So I'll get small wire. I will just attach it, small gauge wire. Do we have here something? No, it's too thick. Everything is too thick here. Okay. Okay, got something. Oh, hi. Sorry guys, I could pause it and get the cable, get the wire, but I didn't, so it is what it is. So what I'm doing is any knife, just as long as I can have some short wire out of it. And I'll cut off first some bit because it was soldered, and I wanna just have fresh wire. Now I'll open the insulation of it, yes, and I want to have only a single wire, only a single core. Why only a single core? Because I'm doing it only for a test. I'm not doing it just that customer will go out with it. Yes, I want to just test it if the power will be on or not. If so, we know what's wrong and we know what to do with it. Yes, replace the fuse if for any reason. Yes, doesn't state, but that's fine. Just solder. Now I will burn myself if I'll do it by hand. So, although I'm tempted to do it by hand, believe me, and I think I will try it. I know I can burn myself. Okay, so it doesn't wanna. Okay, good. Ooh, here is too short. I make it too long in one way. Okay, do we have a? We've got it. Okay, so guys, that's it. You know, for test is good enough. I would just connect it and see if our fuse will blow, because that can be the case, or maybe this TV will turn on, because that can be the case as well. I'll pause it and I'll put this power supply back on. Okay guys, so the first test I will be making is without the backlight. The backlight is not on. I'll put the main light on here. So the backlight is not on. Why? Because if there is a short inside it, I want to eliminate possibilities. Yes, so that's a safer way of doing it. So I'll disconnect stuff here. I'll get this extension lead for myself like this. I'll plug in the power cable, and well, actually safer is to do it not this, leave untouched and do this side. If this fuse will blow, you know, at least you're far away from it. Oh, you see? And it's blown. Why it's blown? Because there is some other issue. and we need to find that issue. Yes, if I would stand here and I would be inserting this cable and I would be close by, that would be really dangerous. Yes, so you see, there are certain procedures which we shouldn't ever avoid. If everything would be okay, you know, then of course would be fine. Yes, but it would be what it was just now, as you've seen. It would be like dangerous to stand here and plug this cable in. We got a good example why we shouldn't, you know, why we shouldn't be here. Yes, now we need to dismount it. I even didn't put whole bunch of screws. Oh, actually no, only 3. I neglected 3 screws. I didn't put them because I knew it might be the case that the fuse will be blown, and you know, there is some other short in it. So yay, let's find the short. But at the end of the day, at least you get a lesson why it's worth to keep up to a good practice of not being close to the place where you know can short. Yes, because you don't want to experience that. Okay, let's get it. Ah, okay, it's connector here. Oh, really? Okay, fuse blown, and we've got an issue with this. So it shouldn't do what it done, but it has a short. So if it has a short on the board, then that's what the case is. Now we can go back to the position we had. Okay, I'll try to move you through this cable. Okay, so at least you know what not to do. Oh, okay, that was actually good that it was here. That was holding you in a good position. I know the picture is not super clear, I know it, and sorry for that, but we need to move on. I've got no time to do setup. If no, I can stop recording and, you know, just continue without the recording. But I want to show you this. Yes, so if I want to show you this, you need to stay with me this way. So okay, let's see. Okay, so we know that this side is a side which goes to this, yes, and it's L, it's written L, so L and E, yes, but it's not a plug which is shorted, which is a good thing, but there is something else shorted. So the first thing what I would suspect it's shorted, it can be bridge rectifier. Okay, I would just follow this line until the bridge rectifier. So here power comes in, that's a fuse, yes, here, and the fuse goes through here. Where's the, oh, bridge rectifier is so far. Okay, so it's that far we need to go to. Yes, that's one, and that's second. So that's this whole line which goes to the first one. Okay, that's the first line. So what we're trying to do now, it's a fuse. Where is the fuse? Fuse is here, and the fuse should go to here, and it's not. We should solder a new one, then we would know it. But when we will solder even, then this comes through here, through this component. What this component is, that's a thermal stuff which is blown. That's not good. As far as I remember, that's not good. Got 2 of them, and both are blown. So these two, and what about this one here, the next one in a row? Where are you? You are here, here, and here. So we've got 3 of them. 1, 2, and 3. Let's check all of them. 1 is here, second is here, this is not, this one as well. So these ones are shorted. I need to check them because I think they shouldn't, these two shouldn't be shorted. This is not shorted, this is nice. This is not shorted, and this should be shorted only if the current would flow. But okay, let's check here. Okay, so we're going, and we've got this thermal thingy, then it goes to here, yes, and now we've got bridge rectifier. Okay, so bridge rectifier, we should understand which one is okay, that's this, but where is the plus and minus? And at the center should be just fuse, I mean the AC. To check the symbol, then I will be 100% sure, but usually is the middle section, there are 4 pins, and all those 4 pins are the 2 central ones are for the AC, and these ones are for the DC. And usually when this this side is cutted, I think it's plus, but I'm not, you know, not good with remembering those things. I just check them each time. Usually it's not always, but it's like most of the time. Let me check and I'll confirm. Yes, I was right actually. So there are 4 connectors in the bridge rectifier. 2, the middle one, are for the current which goes in, which is AC, and 2 outside are for the plus and minus. And cutted side here, see, one side is cutted. I will switch off the light. Okay, so the cutted side, it's the plus side, yes. So both of them, and the same with the second one, I just see. Okay, that's fine. So we know that these thingies can fail, and that might be the case, but I wanted to still check bridge rectifier. And now, as we know that, I'll show you like this. Okay, so let's say we've got a plus and minus, yes, like a fuse and the ground, the same thing, just in the AC, not in the DC. So now what's happening, we go this way through those shorted ones, yes, we go to this side, okay, and we just go up to here to the first bridge rectifier. So from this to this, and from this to this, we shouldn't have any shorts coming from here. Yes, we don't have short, that's good. Now to this, nothing, because it's the opposite way diode. Now here again, it's the opposite way diode, which is here 461 instead of 0, and here, if we will do it, it's okay, sorry. So here is right, because it's 461. If I will do it this way, it will be 1, so that's mean open line, yes, open loop. And if I will swap it, it should be opposite. So here will be open loop, and here will be 461 or 458. Yes, so that's the thing. Now the second one is the same, so we should expect the same. So here we got 4, 5, cool, and here we got nothing, good. And now let us do it the second way. and same story. Okay, so only what we're worried about are those two blue ones here. Yes, those, because the middle one actually is okay, a-okay. So we need to connect connect our probe. Okay, so this one is the good one. No. It's the second side. So okay, now we will know which one. Oh, you see, this one is not. So this one, I'd say. And what about this one? Okay, so the one which is shorted is this one. We need to only find out why. And we need to find other power supply which we can supply this one from, for an obvious reason. Yes, it's not shorted. Ooh, this one is shorted. So it shouldn't. So only one is good out of two. So the same what the other side is showing, yes? So let's get some other power supply just for you for a comparison. And see, that's the same stuff here. Okay. Where's the power comes here, and we've got this. You see, we've got open line when I'm connecting these two, yes? Do we have more? That's the same, so no. Oh, we've got the one which we just had in the previous video. That's a Samsung. Okay, so that's a Samsung, and we've got the same story here. And look, it's not shorted, yes? So that's it. These ones are, but this one shouldn't be shorted, and we need to check why. And once we will replace it, we should check for other shorts as well, but at least the bridge rectifier is not, so that's fine. But these two are, so I need to find schematics, okay, because without schematics we won't know the value of them. And we should put the proper one, because I can put blindly the other one, but I don't want to put blindly. What's the value in it? K320 S14 K320. And what's on the other side, on this one? 14, yeah, that's, you see, these are different ones, so I don't want to put a wrong one. You could put it, probably it would work even, but I might have some LG. Oh yes, exactly, we've got LG TVs. Let me grab one power supply. That's the main board, so no. Let me try here. That's a Vestel. That's a Vestel as well. And what do we have here? That's what it is. Oh, that's bad. I didn't put the sticker on it, so I don't know now which TV it is. That's not good. Peter Pumpkin Eater. What else do we have? We've got some big TV here. Okay, that's Vestel, so that will be Vestel as well, only I don't know why I don't see the name. 49U. Here are the same ones, just smaller ones. But we should have more power supplies, guys, and I know where I got it, so let's neglect it, because I will have to check the component value and put the proper one. I can desolder it and I can mount it back. But that's it, you know, like if I'll do it, you see we've got no connection, yes, in between fuse and the not fused area of the connector, yes, which is the ground and let's say L. Now if we will connect it here, then on both sides of it we've got a hot, yes, and we shouldn't have hot because this, yes, this goes through the transformer here on this side, and that connects with bridge rectifier through vias, yes. So this is a connection. So if this one and this or this, or these two are hooked up together, then they automatically send this signal to the second line. So if you've got a L and ground, they are connected because of these, yes. So these I don't know how they are called, but I think varistor. I don't want to tell you because I don't know these names. Really, I'm not good with naming stuff. I know that it shouldn't short, yes. I know it shouldn't short because that's short to the ground, and that automatically can kill the fuse, yes. So that's why we have this. So actually it's pretty much, so the question is if it will run later or not, yes. But apart from that, you see how to diagnose it, how to know it, and at least the video is 26 minutes, not, you know, not some much longer video. So hopefully you get a value out of it. Probably I'll order these because I don't want to order 50 odd pounds power supply. I can charge customer, let's say 30 including the labor, and I will be happy to do it, yes, and customer will be happy as well. So yeah, that's pretty much it. And these fail, okay, these fail instead of failing whole power supply. So that's like a protection for the power supply. If you want to learn more about them, you can just put anything about switching power supplies or learning electronic repairs. There are a few actually videos about switching power supplies, how they are built, how they are working. There is not many components which can go wrong if you've got completely no light, yes. You see it's fuse blown for a reason, because these ones are shorted. So the power supply is, well, that's a LG. I told you we expect here better quality, which is not that super great, but it's good, you know. So we are seeing that there was only fuse was blown, then the fuse was, you know, hooked up just to see if that's only the fuse without checking anything, you know, which we should, but we didn't. And we found out that the fuse has blown in our eyes, so we knew how to protect ourselves in such circumstance, yes. And then we've checked it out and we see that those thermal thingies, blue ones, yes, which I'll post maybe, or I can maybe open them on your eyes. Oh, they've got symbols actually, they are written. DSC 2.5D 15246. So I can order them. They are the same. Yes, so I can order them. And in that case, you know, in that case, once they will come, I can just desolder them, and I know that the other stuff doesn't look shorted here. I'll check on the capacitor as well. Oh, that's the opposite probes. Yeah, it charged, so it's fine. If it's charging, that's fine. So we didn't even reach, because after bridge rectifier, you know, this will go eventually to this capacitor, and when this will reach this capacitor, if that would be short, so that means something else could be shorted, but as we see, you know, it's not, so it's fine, yes. So I will replace these two and probably will be fine. If there will be no fine, I will record another video about different topic, yes. how to diagnose favor. But it's a hot site, and it's a completely no power, so usually that's it, that's it, guys. So thank you for watching, and see you in the next video. Bye bye. And if possible, let's save them all.